Hello, good evening, everyone. And what a wonderful session. Uh, Today we are all talking about AI being getting into the production era. Then we are also talking about Gen AI, conversational AI, responsible AI, ethical AI. Now today, very interesting topic, and I'm getting an opportunity to speak to a lot of experience panel here, and looking forward for this productive 25 minutes, 30 minutes, and followed by the good conversation here. Basically, when we talk about AI, right, we talk about how AI can change our day-to-day lives in terms of the normal businesses. We also talk about how AI can transform our day-to-day working operations. How can we bring efficiencies? And for all that, if I converge AI with my computing power, because at the end of the day, I'll have to put my AI engine to the production mode. And me from Deloitte perspective, we are talking to multiple clients, and then as we are setting a stage for becoming India as one of the center stage in the world for becoming the power center for the tech and the digital transformation. I'm having this opportunity to speak to the panel. Uh, Let me start with Siddharth. Siddharth, you have been doing a lot of transformations internally for the organizations and also thereby impacting the real world, right? How do you see AI as the game changer in making it enterprise-wide scaling of the technology, specifically when it comes to the businesses and AI playing a vital role when it converges with quantum AI?
Yeah, thanks, Rupesh. Uh, you see, AI is already changing the world around us. I mean, there's no question. I mean, even now, if you go and visit any website and open the genie or whatever the help person which comes up, and you don't even realize that's not the real person.
Yeah.
That's mostly AI talking to you. It understands what you are asking, what is the objective of your queries. It ignores your grammatical and spelling mistakes. It ignores the type of language you are using, and it gives you the answer. I mean, now it's up to you and the organization to harness the real power of AI and make the best out of it. So you have to understand that AI in itself can do whatever you teach him to do, right? So, and training the LLMs, training the product that you have, the AI product you have, and contextualizing it. Uh, you can do a lot many things. Now, I'll give you a mathematical analogy. Y is equal to whatever x, right? Kx is something you can do. You can take some time, but you will be able to do. Now you expand this equation to not one variable, two variable, but hundreds of variables. How do you do it? Now with quantum coming into picture, first it was CPUs and then it was with AI it was GPU and now it is qubits with quantum.
Correct.
Uh, and and the power of quantum is that you can do this complex hundreds of variables equation in about fraction of what AI does it, using the classical CPUs and GPUs. You also now understand that with quantum, there is something called as randomization, your entanglement, and supposition. So these three variable, uh, first it was only binary that used to work. Now with quantum, you can work with both zeros and ones together. So on one hand, you can have a big data and try to make sense out of it. But on the other hand, now you change these variables, combine it with the big data, and try to make sense out of it. So that's how fast and how comprehensively the world is changing around us. I think it is up to the organization. Now in healthcare, I think there are lot many things which AI and quantum AI is doing. Obviously at a cost. I mean, quantum GPUs chips are in shortage now. I don't know what about the qubit chips, when it will come and how it will come and what is at what cost. But at that cost, if you can combine all these variables and arrive at something, the answer which is closer to, which is quite accurate. I think that's the power of quantum AI. And the case studies, like to give you another analogy, you have genome sequencing.
Yeah.
You use AI to understand the genome sequencing, and on the other hand, you have this diseases data, like in pharmaceuticals. I'll take that analogy because the clinical studies in pharmaceutical take decades, right?
Yes.
And you saw the last pandemic, the vaccine had to come out at a very fast rate. So how do you keep the drug safe, but at the same time increase its efficiency? Is by working with this data. And whatever tool helps you in making sense of this data, giving you an accurate result, is the game changer. So if the clinical studies can be reduced from decade to a few years, that's how you will get the drugs faster, cheaper, more accurate drugs. I think that's a real world example.
Absolutely. I mean, I'm really impressed with the way things are changing, specifically in the healthcare space and the drug research space. I mean, cutting down the time of the drug, right from drug discovery to the production and to the market, right? So they impacting the end-to-end supply chain. And that brings me, I mean, from a real-world application, Nikesh, I mean, you have been pivotal in doing many real-time applications to the use, right? So maybe you would like to contextualize and give some examples for the benefit of all?
Yeah, so if you look at my 16 years of career, first 10 years I was working on a supply chain area, and from last 6 to 7 years I am with the financial sector. So I'm going to quote a couple of problem statements which I was trying to solve as an AI scientist, where I realized if I would have been given more compute power, I would have done better. So I was working for a company, Fortune 1 company, Walmart, and I was supposed to design a logistic planning for the perishable items. If you know Walmart, which is 500 billion and 500 trillion company, a Fortune 1 company in the world, their perishable, if you talk about their total disposable wastage in the perishable supply chain is more than 2 billions. And designing a supply chain logistic planning, which get the items from a farmer, bringing to the stores and delivering to the customer as fresh as is possible. And there I was trying to solve something called route optimization problem. And if you're talking about, let me use some technical jargons. That problem is known as NP-hard problems. What is NP-hard problems? It takes infinite time to reach to a solution, which could be a good and optimal solution, because nobody knows what could be the optimal solution for that problem. So I was trying to develop a genetic-based algorithm. And that time, I wrote a mail to my overseas counterpart asking for the GPU machine in year 2012. That time, GPU was as hot topic as what quantum AI looks like today. And they got surprised. Who is that guy from India asking for a GPU machine? Then, with the GPU machine, even when I was trying to optimize that problem, I could not reach to the most optimal solution. I could have to compromise on a suboptimal solution. That point, I thought, if there could have been something like in quantum AI, that would have saved my solutioning approach, as well as it would have been yield a big impact on the Walmart when it comes to perishable wastage. Second example, when I was working, currently I'm working in the insurance sector, which insurance is all about risk estimations and doing a proper underwriting and a pricing. And today, the way we do a pricing and underwriting, we use limited variables and limited feature. Because the only things which becomes a bottleneck is the speed, because we have to take a decision very immediately. If a customer is coming to my counter and I have to do a risk assessment, I don't have a 30 minutes time to do the risk assessment and tell customer, worthy for this policy, you are worthy for this policy. It means I need to get a decision in 3 microseconds. And for arriving to that decision making, I need to analyze billions of records and trillions of other features to come up with the fact that this looks like a good business proposition to go ahead with that. There I realized the compute power would have been there, that would have made my life easy. I was, for a small 1 and 2 years, I was spent in a healthcare as well. I was working with a company who was consulting to one of the largest pharma companies of the world. There I was doing a cancer propagations prediction problem. But the idea was to predict a customer who is in stage L1. What's the probability he will progress to stage L2 and go to the metastasis stage? Their idea was to give this information to the pharmaceutical company so that they can expedite their drug discovery, and as well as whatever drugs are available, that could be positioned to the locations where the patients are suffering the most. There I required speed and accuracy, because this is not something, it is something related to the human life and and it is a critical care for the cancer diagnostic like that. There would have been a compute power of quantum AI, what we are talking today, that would have made my life easy, and that would have saved a lot of lives. There are some of the real world examples from this, and if you ask me, as per the McKinsey digital reports, in the financial sector, if by 2035, the quantum is going to become a mainstream. If that becomes a mainstream and we only realize 50% of the potential of the quantum AI, do you know how much value it is going to add to their economy? To the financial sector, it is not less than 622 billion. So we are talking about a big money, but the only challenge when it comes to the quantum compute, when the quantum compute will come into the full-fledged, do we have the right skills available in the market? As you know, AI, developing the talents, hiring the talents, and the attrition rates. It will still be a challenge for most of the company, even with the Gen AI. Most of the companies are talking about, but they don't know exact formula. If somebody asks me, what is the productivity improvement and how much top line and bottom line is being impacted by this Gen AI, nobody has answer. Same question will come when it comes to quantum AI. Let us say tomorrow, CI go to a CXO and propose, I want to bring a quantum compute. The only thing which will come, the table that what value is going to bring. If you are not able to justify the cost-benefit analysis of the quantum compute at particular time, this once again it becomes like a theory. We have seen multiple waves of such technology changes. One is the big data, where the world was hoping this is going to change. Then it comes AI ML. Due to data quality and all, most of the products which are being built on the data, on the AI ML, only 1/3 of the project are being productionized, because integration issue, legacy issue, change management, all are becoming the bottleneck for the AI to become successful. The story is not going to be different for the quantum AI. Once again, same people, same mindset. Are we going to train our generation, the current generation, and we're going to train them how to use Gen AI, and then how we're preparing them to use the quantum AI? Ultimately, when the quantum AI will come to the picture, I will be somewhere retirement age. I don't have to worry about it. I think the guys who are in the 20s, they're starting their career, they have to pick up those skills so that when it comes, the quantum AI, they can pick up those skills and they can bring value to the table and justify what investment required to run a quantum AI to bring benefit for the sectors and for their companies.
Absolutely. I mean, thanks, Nikesh, because at the end of the day, we are in such a transition state of the affairs that every company is becoming a digital company, right? Every one of us, either the consumers of the platforms or we are actually developing the platforms, right? So platforms become the end. For the platforms to operate seamlessly and touch our day-to-day lives, we obviously need to have a compute power and obviously AI. So that brings me, I mean, because AI is going to touch our day-to-day lives. So Harshal, I mean, from a competitive edge perspective, like, and the way businesses are transforming, what do you feel, I mean, based on your experience and interacting with so many clients, like, what are the sectors which will get impacted by quantum AI?
I think some of my colleagues here already kind of touched based on that. The sectors that need a lot of computing power, and he himself struggled, right? He wanted that computing power, but it was not there. Correct. I think those of them, all of those will immediately get impacted. He was talking about the drugs kind of, the drug discovery kind of thing. There are also newer applications that will come out, when this kind of sheer power is made available, right? Cryptography will definitely benefit by it, because not only it can make things more secure, but on the other side, it can also help to break things, right? I think it's going to be a scary world, if you ask me. Because, see, to quote Captain Kirk from Star Trek, we are talking about where no man has gone before, right? It's a completely uncertain world. We were talking about governance. It's a Wild West, literally. Right? So while the businesses, startups, very insightful session, the previous one, startups, all of these will benefit by the sheer raw power that quantum AI would offer. I mean, just quantum computing will give so much power. And on top of that, if you put AI algorithms, it's going to be crazy, right? But how do you really utilize this power is going to be the key. And I think one of the previous, person from the audience said, he talked about World War III and the moderator was scared, I mean, we are talking about that kind of power, right? It can monitor everyone. It can listen to all conversations. You have all satellite, I mean, Starlink is coming to India, right? Governance? No governance. Okay, someone sitting somewhere in the world can listen to what you're talking. And with quantum AI, it's going to be, I mean, at the spur of the moment, you're tracking streams, billions of streams.
Yeah.
Who is talking what? Who is discussing an investment decision? Who is talking about where, there is going to be an attack? Whatever, I don't know, right? All of these things are applications, and I think AI is struggling with responsible AI. I think quantum AI would need even more. Guardrail is a very loose term, I think. It will need more stronger kind of, things that can allow it to do. It's more like, cloning,
Yeah.
right? It's on the lines of that. Do you want to play God? Is what the thing is. So I will not take more time because I would want my other colleagues to also speak.
No, thanks, Harshal. I mean, really valid point with the way industries are changing rapidly, and at the same time, being on the industry side and making the use cases live, right? There are, industries which are actually giving too much of efforts and a lot of dedication is going in the adoption of quantum AI, right? And I would like to hear from Kavindra, from your organization standpoint, what are the measures that you are bringing? Because with data coming in, data lakes, pounding in, you have AI use cases who are actually getting into the banking sector, the various sectors. So what are the adoption measures and what are the challenges that you feel from the adoption perspective?
See, from quantum AI, I mean, it's a very big topic. Currently, we are talking about AI, and now we are talking about quantum AI, which is way beyond our expectations. So I cannot say that we have started implementation of quantum AI because it is very starting phase currently. Okay, starting phase. It started the research, or I can say the OEMs, cloud service provider, they have started giving the quantum processing unit way back in 2019. So we are in 2024. So they have already realized that this is something which is going to be needed in future, and that's how they have they have started the development work, research work, and all. From banking point of view, we have not done anything yet on quantum AI, but yeah, definitely we are doing most of the things. There are multiple different things we are doing in AI. But from challenges point of view, I heard from the panel that this can leverage so many benefits and all. But we also need to be mindful when we are talking about quantum AI. Okay, very first thing is the hardware. When we are talking about hardware, I just wanted to so when we are talking about quantum AI, it is basically quantum computing plus AI. Okay, so quantum computing, I can, if I compare it with our classical computing, which is currently, which everyone is using, and it's currently in there. The processing units which are available in classical computing, they are so many. I mean, there are multiple different processing units. You just name it, you ask for it, and you will get it. CPU, GPU, those are there. But with quantum AI, the requirement will be of quantum processing units. Our CPU, GPU is not going to work anymore. Okay, we would be needing quantum processing units. We already spoke about bits. The classical computing use bits. Quantum computing is going to use qubits. There are two major, I can say, terminology which quantum computing normally use. One is superpositions, and the second one is entanglement. It is something like, we are changing something here, and the way the qubits are connected to each other, the state of the connected entity is getting changed automatically, which is far beyond, it's mile beyond the very first state. So, the states are connected in a way that if one change is happening in one place, the other state is also getting changed. So you're talking about hardware. You just consider that building this kind of hardware is going to be very, very much expensive affair. Although the cloud service providers, they have started giving certain QPUs in the marketplace. But if you talk about those QPUs, the cost coming for those QPUs, they are very. They are talking about the very common QPU which is currently there in the marketplace is IonQ. Okay, it work on task and the shots. So we need to pay for number of tasks we are running, and inside those tasks, how many shots we are executing for that particular task. So you can consider the way we are talking that one task is going to be, or one processing is going to be completed in microsecond. How many tasks I'm going to perform, and how many shots I'm going to perform, and what is the cost which is going to come. So it is going to be very, very costly currently. So we are talking about quantum AI and all those things, but we also need to be mindful that the cost which is going to come to implement that particular hardware, it is going to be very, very much expensive. The software, when we are talking about AI, currently we are talking about the algorithms which are there. We are not very much sure that to solve our current problems. Like I heard from one of my friends that the weather forecasting is not that much accurate, which where we use AI. So if my weather forecasting, AI logic is not that much accurate, how can I implement the same algorithm in quantum computing? I cannot, because I know that I need accuracy to run something in quantum computing. There are algorithms available, but those are very much erroneous algorithms. People do iterative, I can say builds to come to a error-free kind of error-free algorithm. So the current algos which are present, those are not very much error-free. So we also need to build the software as well, which is going to be the base to run a quantum AI. So talking about hardware, software cost, nothing, if we combine everything, we are not very much into a position that we are going to implement quantum AI at the moment. The skills in the market, okay? AI, we are struggling to get proper skilled resources. Talking about quantum AI, where we are looking for a person who knows quantum mechanics as well.
Yeah.
It is not possible to get a person who knows quantum mechanics, who knows AI, so this is also something which is going to be a very, very much challenging factor. When we are talking about adoption, let's say, I'm talking about 15 years or 20 years from now, we cannot just implement quantum AI as is. There are multiple different regulations which needs to be put up in place, policies needs to be put up in place, because we know the power of quantum AI. Quantum AI can breach anything, okay, in couple of microseconds, okay. So we can just think of and we can get the output, okay. So we need to have proper policies, proper regulations in place to implement quantum AI. This is something which is a very big topic we are discussing today, but this needs a lot of discussion, a lot of thought process to implement it. So there are a lot of challenges as of now. Adoption is not that much easy the way we are thinking. Yeah. So this is what I wanted to say.
Really wonderful. I mean, and then we all agree, like, because we are talking about two large topics, and then it's going to change the future. I mean, what we have seen in last 10 years has completely transformed the way we operate, the way we work, and the way we interact, right? And I mean, while all the sectors have got impacted, like, obviously banking and financial services are the ones which are fast changing. One of the sectors that we are seeing, like, as a firm is picking up very, very fast is the manufacturing, right? And that's where I would like to ask Ashok that, Ashok, where do you see, I mean, we are talking about Industry 4.0, we are talking about IoT sensors, data getting collected from various manufacturing lines, assembly lines, and thereby impacting your supply chain, right? So where do you see the future, like, the next decade? We spoke about the challenges, we spoke about the kind of possibilities, right? So from a manufacturing perspective, we'd like to hear from you.
Yeah, I'll talk about the manufacturing only, because I'm in manufacturing since my career started. So what I saw in my past, this is, everything is the change. It's a change management. So computing was very costly at that time. And people were saying that it's very difficult, this and that, and governance is also tough, how we will control, but everything is happening. So it's a change. We have got change from computing 286, 386, 486, Pentium and all that since today. Now we are talking about the AI. I was thinking whether I am working in the manufacturing segment. I don't know whether we can use the AI or not. But today I would say that I myself is using AI in my company.
Actually,
There is a use case which we are going to live in next couple of months. But we have started it. So what we can say, see, when there is a way, say there is a way, things are there. We are talking today, we are talking quantum AI and quantum compute. Definitely, see, in today's scenario, if we'll see, when somebody in the back end, OEM started using it. So yesterday or day before yesterday, my wife was telling me that my phone is listening. Then how you could say that phone is listening? She said when we talk something and the ad comes.
yes.
Okay. So she also switch off this some devices when she talks something. So see, in the back end there is quantum started, people has started, the governance will come, they will manage, and maybe from the basic stuff they will start, and later it will come in the force. So we should be ready, and the way is there, it will come definitely.
So obviously, I mean, and with the way the entire manufacturing sector is
And the
becoming.
cost will also reduce. The
Yes.
computer was very costly in the beginning, but today cost is okay for us. So that way it will come now. And the intelligence will also increase. Talent will come.
Yeah.
Manpower will come. Everything will happen.
Yes.
But the way is there, roadmap is there.
Yeah.
Yes.
Yeah, obviously, I mean, we are top of the hour, and that brings me to the last question, and maybe I'll ask Nikesh, based on your past experience, with power there comes the responsibility, right? So, what are the governance measures that, you feel that we should be, as an organization, we should be prepared with?
Yeah, if you look, when we are talking about quantum AI, so almost all the governing principles which governs the AI is going to be the same. So we are talking about responsible AI, then we are talking about responsible quantum AI. So even if it is quantum, Gen AI, or simple AI, or simple data analysis, the key is data. Data quality is the most important one. With the compute, if you don't fit the right data, you won't get the right output. So there are two things: no data, no AI; low value data, low value AI. You can't expect feeding a wrong data and expecting AI to do magic for you. So that becomes a constraint. If you want to become a superpower with the quantum compute, today you have to put that foundation of how to improve your data quality.
Ego.
There is no other way. Second point, as my colleague was suggesting, the phone is listening, data privacy. That should not be compromised. Even with the quantum AI, with the GNI, whether it is AI. Whatever it is, the privacy is the topmost. And with the quantum AI, which I think the most governing, we require biggest governance is about data security. Today, data breaches are happening. Every day there is a news. This company data has leakage, that company data has leakage. With the quantum compute in the wrong hand, can do a lot of decryption for all of your system. None of our data will be secure. Now, how are we going to build that kind of security today, so that tomorrow if you compute of quantum compute is in somebody wrongdoer, they should not harm us. Now, how are we going to build that kind of CISO principles, and how we are going to secure our data? Third, explainable. Today, if you talk about AI, AI seems to be a black box. What it seems? Input and output. What we are interested in, give the input and get the output. But if you want to build the trust on AI, whether it is the quantum AI, whether it is Gen AI or simple AI, you need to explain why AI thinks in that way. If until you bring the explainability, it won't. And one more thing with the quantum AI, quantum computing, this can be done in a very distributed way. Let us say, if you're building an AI solutions for Pune versus a Bangalore, the feedback comes in a two different way. The same feedback coming from a Delhi, same feedback coming from a place in Lucknow, it doesn't mean the same thing. And how do you train your AI model to take those feedback, act locally, and make sure that person who's giving a feedback, when they see the next time AI output, they see that my feedback has been taken very seriously, which brings to a topic called federated learning. So, data security, data privacy, and then your responsible AI, explainable AI, and your federated learning. These are the things has to be taken care, and on top of it, we need to build very nice encryption, decryption algorithm to make sure our data is quietly secure. So that, I think that's bring to the topic, how we are going to govern quantum AI in 2035, not today.
Absolutely. I mean, going step by step is the key message. Thanks for the insightful session, and thanks everyone. I mean, we are on top of the hour, so I don't want to come in between the dinner right now. Maybe we can take one or two audience questions, if at all. We are up the time, right? So, okay, maybe we can discuss offline on the stage. But once again, thank you so much for the insightful session, and really privileged to share the stage with the thought leaders here. Thanks.